That is done. We are recording now, and want to welcome everyone to this session with John, VE3IPS, who's doing a presentation on the misunderstood tilted terminated folded dipole. Feel free to ask questions in the chat and or participate in the chat, as well as ask questions in the question and answer area as well. And we'll catch that a little bit later on after John's presentation. And John, I'll basically turn it over to you and feel free to go ahead.
Okay, great. Just want to confirm everybody can see my screen with the title slides.
Yep, certainly.
Okay, perfect. Thank you. Good afternoon, everybody. I'm glad to be here. And this is what a great event this is with this virtual conference here. And, you know, first time for the club. I think everything's been going really, really smooth. So my talk here is going to be on the misunderstood T2FD antenna. And the reason I kind of chose it misunderstood, because I surely didn't understand it. There seemed to be a little bit of confusion around it. So hopefully I can clarify some of the confusion, but probably motivate you guys to make your own antenna as well. So with that, we really got to go back to 1949. This is really kind of when it all started by Gil Countryman, who wrote an article in QST on experiments that he was doing, and that's how they came up with this kind of terminated, tilted, folded dipole antenna, typically known as the T2FD. And it's an interesting antenna because it does offer a 5-to-1 frequency bandwidth, so that can be very interesting, because in many cases you build a dipole, you're building it for 40 meters. Here you're building a dipole that could be from 80 meters and up. The biggest complaint from this antenna that I've been finding is that everybody's complaining about power being lost in the resistive element, and that is true. This antenna will be several dB down to a dipole. It could be half an S unit, could be a couple S units, depending on the frequency, but its wide range and low noise capability is probably something that would be very, very suitable for an antenna to be used, especially with a lot of this plasma TV interference that I get on 80 meters. It's kind of preventing me from actually operating on 80 meters. Interesting enough too, if we go back to the Signal Corps, they were also using this antenna as well, and they were using it with a typical man pack of 10 to 20 watts, and they were able to make contacts with it. And other people are using this antenna for AIL or cell call usage. So a lot more AIL activity, probably more so in the US, sending messages back and forth across wide frequencies. And in Australia, a lot of people are using the cell call that they use out in the outback. Now, the thing that's nice about this antenna is it's broadband, low noise, and has manageable SWR. So those are kind of the attributes to using this antenna. So here's a typical T2FD installation. It's typically mounted on a pole, typically around 30 feet off the ground, 36 feet off the ground, and then 6 or 8 feet at the other end. It's tilted in order to give this omnidirectional capability. And as you can see, it is a folded dipole. There is a balun, and there is a resistor. Now, they typically mention this 30-degree tilt, which for some people, it can be a problem to try to get this into the garden or in the backyard. So here's some commercial examples of this antenna. Actually, I just found out recently that Palomar added one, and they're calling it a broadband terminated dipole. So they have their version of that antenna. Probably the one that's well known by the military and diplomatic agencies is the Barker and Williamson version. I actually found one of these at a ham fest. I have not had time this year to get it up and put it up, but it looks pretty well identical to what's in that picture. The cardboard tubes are just to kind of hold the wires from getting all tangled. On the right-hand side, we have a version here from Buxcom. Again, they have their variation of this, and you'll see that what a lot of the misunderstanding is there's around different configurations and spacings and lengths and baluns and stuff like that. Here they show a typical SWR. It kind of shows everything under 1.4 to 1. I haven't found that myself personally. So there may be some variables in how they came up with this. Obviously on the, I've got a couple of antenna analyzers that are coming. I'm gonna be able to do some frequency sweeps when I get this antenna back up in the air. Here's one I saw in Japan the other day from another company. This one's a little bit different. They kind of got a little bit of a different shape to this type of antenna. And then on the left-hand side, QRP.biz, there's an excellent article and a couple other articles, antennas for people that like to play with antennas, that will that has some examples of an antenna being built there as well. So here's the, the common BDW90, the B&W one. They've sold thousands of these antennas, and typically the way that they show it is in a horizontal configuration. However, it also can be installed in an inverted V configuration. So for me, what I was looking at doing was I wanted to really consider mounting this in an inverted V configuration, because I just don't have the space in my backyard in order to put it up the way that I want. And since it's a folded dipole, why wouldn't I be able to do that, right? We're just doing some experimentation. And I've seen various military antenna suppliers also showing it in horizontal, sloping, or inverted V configuration. This picture here is from the, I think it's for the ICOM version or the ASU version. And here we have the ability of trying all three for fun. Now I have set up this antenna out in a park in order to try it out. I didn't get the same height that I would have expected, but I was very, very encouraged by the results of the antenna out in the field. So let's look at some of the components. So there are really three design issues. There's this resistive element that is a variable. There's the center balun itself. That is also a variable. And then we have our end supports. The end supports are probably the easiest things to figure out. So the typical formula for this is that the lowest frequency coverage determines the length and the spacing. So there are calculations to figure out the impedance of the resistive element. I've seen this anywhere from 330 ohms to 800 or 900 ohms. And then we have variances in the balun itself as well too. And then we have the spacing. And I have some calculators that a gentleman had put together that can help make things a lot simpler when you're designing your own antenna. Here's another one. This one uses a different example. Just to make things a little bit more confusing, is it just very specifically chooses a 390 ohm resistor, and they're definitely looking at using a 4-to-1 balun. Calculation numbers kind of all work out the same. And then here they're using 75 ohm coax to the receiver or transceiver, which normally we would use 50 ohm coax. So M0MLK had put together this calculator. Grab the link to go download it. Somebody wants to put that in the chat box, please go ahead. And it's a great little calculator. What I found even more confusing and starting to misunderstand was the fact now that we had 3 different versions of this T2FD. So I kind of chose 7 megahertz, figuring, you know what, it might be something I'd be able to fit in my backyard in an inverted V. So the full size, it's going to be 70 feet long. That's not going to fit horizontally in my backyard. There's a USN model, which I'll explain in the next slide. And that one is 46 feet. Okay, that's still going to be a little bit too tight for me. And then we have a shortened model that's going to be 35 feet. Okay, so the 35-foot version could work for me. And again, it's got the spacing between the 2 elements because it is a folded dipole. So here's some of the notes. So the full-size model is based on the original US Navy design. that was done back in the 40s and 50s there when Gil Countryman started all this off. And it basically refers to it being a half-wave model. So it's a half-wave folded dipole. And then we have the shortened model, which is a quarter wave for restricted environments. And of course, that's probably not going to work as well as a full-blown model. And then in between, we got the US Navy model that's kind of going to be maybe the one that fits in between, between efficiency and optimization as far as performance based on the length. Obviously, on the lower bands, the longer the antenna is, the better it's going to work. You could also, as its recommendation is, to install it as a sloped antenna for best results. However, you can mount it as an inverted V, which I have done, and I feel my results are probably just as similar to having it set up as a tilted antenna. So now we have the feed point. So the feed point is really, in my case, I used everything to be 50 ohms. And we could either have a 16-to-1 balun, a 1-to-1 balun. There's also variations of a 820 ohm resistor in different balun size that can also be used. And then, you know, the traditional feed is really to mount this with 300 ohm twin feed and then put a balun in between with that. So now let me explain a little bit more about the resistive elements. This shows this to be for 3.5 megs on 80 meters. So obviously on 80 meters, a full size is going to be 140 feet. The USN model, which is typically the ones that you see like B&W has, that's around the 90-foot range. That is going to be your typical T2FD model. And then we have the shortened model at 70 feet, still too long to put in my backyard. But because I made this in a modular format, as you'll understand later in the presentation, it's very, very easy to do things in order for to do some experiments. So I had a really big aha moment, and that happened when I was digging through a couple of the old 73 magazines that I had. And as I was going through looking up an article, I came across this one here for the T2FD QRP antenna. Oh, okay, let's take a look at this. What does this mean? And, you know, basically it is the same T2FD. They're feeding it with 300 ohm twin lead. And then what I saw that was really interesting here was, A, there's no balun component, it's just a resistor itself. I could fit this in my backyard because it's 40 feet, which is the width of my backyard. So I could go with the shortened antenna for 40 meters. And since I don't do much activity on 80, this would be perfect for me to use on 40 meters and 30 meters. And if I wanted to run this as a tilt angle, then I could. However, I could mount it at the side of my house and then angle it across the property and have it still off the fence, 6 or 8 feet off the ground very, very easily. So in this case here, I was using 300 ohm twin lead, just like the article. I used 390 ohm resistor. And what I did is I took 10 3900 ohm resistors, the 2-watt versions, and I mounted those in parallel. So now I had my 390 ohms. I have a 20-watt resistive element that's going to be fine for QRP. It could support up to 50 to 60 watts of CWT down. I have tried that. The resistive element is typically a quarter of the maximum power rating. So if you're going to put in 100 watts, you probably need to have a resistive element that's going to be at least 25 watts for CW. Now, some of these designs were showing different resistors, you know, 390 to 800 ohms, depending on the feed line you're using, based on the different balun impedances. Some use a 6-to-1 balun, 9-to-1, 12-to-1, even a 16-to-1, which makes it a little bit more confusing. And then I thought, hey, how do I make this thing stiff? So I ended up making the center component to being an aluminum bar, because that was just something I had in the workshop lying around. And then for the end pieces to space the wire out, I ended up using fiberglass tent pole mass, which worked out very, very good. Originally, I was going to use a PVC tubing, but I didn't think it would be rigid enough for the distance. And it does tend to soften somewhat in the sun. So for long-term use, probably the best thing to do is maybe use a piece of bamboo, a wooden dowel that's been shellacked, or using this fiberglass tent pole would probably make things so much easier. So now the next challenge was how to connect it to the radio, but continue to stay modular. So the local electronics shop that I go to has these Hammond project boxes. They're turned out to be perfect. I've made a lot of different things inside those little project boxes. It's the 155, 1 kbk. They're like $3 each box. And I decided to say, hey, you know what? Why don't we try the 300 ohm twin lead? Let's just do that as per that article. I ended up using 35 feet. That's what I had lying around. And I remembered I had a balanced line tuner, so I went digging in my boxes to find my MTech BLT. So I thought, hey, why don't we use that so I could lower the SWR to where I need it to be. And then the other design element is the spacing. So depending on the frequency that you're using, there is a variation in the spacing from anywhere from 18 inches to 34 inches. I decided after looking at those calculator charts that the spacing could be all over the place. So I said, you know what, it's a folded dipole. How bad could this be, right? I'll just make it 18 inches. I've got tubing. The mass tubing was about, I think, 20 inches in length. So I think I'm okay. I got an inch on either side. Let's try it out. I'll make a smaller version because I just want to try 40 meters for now. And then I'll build a 90-foot version so I could try that out as well. And of course, I made it modular, right? So I could just snap in my components as needed in and out. Now, the longer 90-foot design does offer lower SWR than the shorter version. So in some of these examples where we're starting to see across this 5-to-1 bandwidth that the SWR is under like 2-to-1, I believe it's really more towards the 90-foot version because I didn't see the same kind of impedance values when I did mine. Now, when I'm going to try these new VNA devices, I'm going to have a better opportunity to now do a proper SWR sweep to have something put together. And when I do that, I'll put those up and send them to Chris to put in the into the Sprat bulletin. Okay, so enough of the theory here. Let's take a look at the elements that I actually put to here. So again, you know, the whole concept of this, how do I put something together that I could, you know, experiment and fool around with? So I have my wire elements here that are the shorter elements. I have a loop on it. I took a small little lead element with the two little holes in it that I could squeeze together to compress to hold the loop in. And then I have a short 6-inch of loop of wire with a little connector on it, and I could plug that into the box. So this white box here, I have a 390 ohm resistive element in it. I've also made one with 600 ohms, and I also made one with the 800 ohms, so I could try different things out in order to see how that affects the SWR with my antenna. And because I have these connectors, I can just clip the wires in and out as required. And on the right side, I have my black box, and I chose it black because that was going to be my feed point. And what I did is then I made a hole, put some RTV sealant in there, and I've got my 300 ohms. And then I got some banana connectors on that for the 300 ohm wire. And again, I can snap the wires in and out. I also made a second box with a BNC connector as a straight through. And I made another box that has an SO239 connector on it. So you're going to ask, why would you do that? Well, because it's modular and I can experiment with it. Even though I have this bar up on a mast, I do have the ability as well to use this for other antenna types. So here's another viewpoint of, here's a little bit of a closer view here. And again, here, this is just to show you how I have my connectors here on the plastic box. And then I have a Night and Ease carabiner here that I can clip the wires in and out. So I have the ability of making changes on the fly. One thing I'm not 100% happy on is you can get these wires tangled if you're not careful. I may need to be, I was thinking I may want to put some extra spacers in between there in order to make sure that for a field antenna that I would like to take out for field day or an operation on a picnic table operation in the park, I don't want to be fussing around with an antenna that's going to take me then an hour to get up in the air. I want to get something up in the air in like 10, 15 minutes, and I can definitely easily do this with this antenna. So here's another viewpoint of it. Again, just a little bit more of a tighter view. The one that's probably more important here is I have a Klansman mast here that on the top of it, I have a 3/8" stud that I now can put my that aluminum arm on it. So obviously it's going to be stiff, and that allows me to put it in a horizontal fashion, but also in a vertical fashion. In the vertical fashion, and I didn't take a picture of it, is that I have the ability now to hang with a loophole here and a carabiner. I can hang this off this mast arm here. You can see an example of it here. There's an eye hook right here that would allow me to hang this off. So I could also put it in a horizontal format using the same type of Klansman type mast for portable operation. So I found that to be very, very useful for doing experimentation. Okay, so I'm building different baluns. I have one that I made for a larger broadband antenna that is 270 feet long, and that one is a 16:1 balun. So I'm gonna try that one out. I should have added this into the list, but I'm gonna make up a couple of different baluns, 6:1, 9:1, and 12:1, just to experiment with, and that allowed me to use different lengths and different resistive elements to kind of see what the different patterns are going to look like. And again, because it's modular, I can swap things in and out as needed very, very easily. And, you know, again, I set it up so it could be mounted vertically or horizontally, or even in an inverted V configuration. So I have a bunch of different options. I've also tried some NVIS activity. So there's been a lot of interest in the 5 megahertz band. You still need the workable FOF2 frequency for NVIS activity, but when I did bring it down to around a 10-foot height, the SWR did change, of course, because it's closer to the ground and there's some ground losses associated with it, but it was nice and quiet, and I was able to hear some CW signals come out very, very clear later on in the evening when I was getting propagation activity that would support NVIS. Again, I mentioned these little 90s brands, carabiners. They're about 1 inch long. They come in metal and plastic, and you would buy them as part of a keychain. So that allows me to snap the wires in and out very, very easily. And now, because I told you before, I have a BNC element. I have one feed point that has an SO239 connector. I can kind of use that arm now. I can use that now for any sort of an NVIS antenna, or I could just run regular dipoles out of it. So I may have in my antenna box, maybe I have like a, you know, appropriate size toolbox or an ammo box, and inside it I have the NVIS antenna, I have my mount, I have the aluminum bar, I have a series of different boxes in there. I could also look at adding a traveling wave antenna, which is kind of another design. So now I could have all these in the box with a couple of dipoles for 80, 60, and 40, and 20 with the wires in there, and I can snap them in and out as I need it. So now I can have kind of a go-to box that has some different antenna element that can help me out when I'm out in the field to do some operation. So that's it. Thank you very, very much. I've got my email address there if anybody wants to know anything. I've been a member for G-QRP in a long time, and I guess at one time I lost my membership number and they issued me a new one, which is fine. That's okay. I almost feel like I'm a member twice, and I still have my old G-QRP pin from, I don't know if it's 1981 or 1979 or 1985. So little story here on the picture here was my birthday the other day, and my daughter and her boyfriend spent the whole day putting together a radio that would kind of resemble the ICOM 705. So not quite the ICOM 705, but it was a delicious cake. They got the mic right, and I was really curious how they were able to get the curly cord together, and they said they didn't really want to talk about it because they spent more time than was necessary to try to get the curly cord. So with that, I'm open to, we got some time for some questions.
Sure. Hey, John, thanks for the presentation. It's really good. If you do have questions, please ask them through the chat feature. Anthony K8ZT has put on a link to the website for the calculator.
You've gone on.
Also, I muted myself for a second. Also, again, if you have questions, bring them up on the chat feature. As I mentioned, Anthony has a link to the calculator for the folded dipole. And I do apologize for the binging noises. Several of you are going in and out of the meeting, and for whatever reason, we've not been able to mute that. We're in a frenzy in the background trying to see if we can take care of that. But in the meantime, we do have a question about the radiation patterns. Do you have, John, anything on the radiation patterns for the folded dipole?
No, I don't. I haven't been using any of the radiation pattern tools. When I gave a version of this presentation at our local amateur radio club, our president sent me some of those NEC, NMA kind of things and stuff like that. I think if you look on the web, you'll find some references to it. It is more of an omnidirectional pattern, I believe, in the tilted configuration. I can't really say what it would be like in an inverted V. To me, I would just assume it's like a dipole. But you know, my kind of intent experimentation, I kind of don't get caught up in these analysis and wire line diagrams and you know these bubbles and donuts that you see and stuff like that. To me, it's just, you know what, make the antenna, spend an afternoon, put it on the air and go out and have fun with it. And don't worry about, you know, if it's going to work or don't work. Just go try to make some contacts and stuff like that. I just found that there was never, for me, to have a proper, you know, reference point or a way to actually say, hey, this really is the type of pattern. And as far as the wire size, I just used what I had on that spool. So because I'm using a shorter length, it is number 18 gauge. I would think if you're going to the 90 foot or even 120 foot longer type of antenna, you probably want to use a longer stranded gauge, maybe more like a number 14 or number 12. The B&W one uses that copper weld stranded wire. It's just bare copper wire that's stranded. I believe that's a number 14 gauge. I find that wire is okay for a fixed use, but if you're going to roll it up and unroll it up and use it for portable operation, you probably just want to use a PVC coated wire.
Okay, and one of the things that I've used in the past for antenna performance, actually in the field, is using the reverse beacon network. Using that and transmitting out on your antenna gives you an idea, at the very least, of that you're getting out, and secondly, you know, what your distances are and what your coverage areas might be by what beacons you're actually tying into and getting feedback from. Another question from Dave G7WHI. Have you been able to compare this antenna, or are you aware of comparisons between this and a standard one-wire dipole?
Yeah, I've done an A/B switch back and forth to take a look at the differences between them. I find that the T2FD, it's a quieter antenna. It's a folded loop, so there is some inherent to the design. It's going to be quieter. I also find that it could be 2 to 3 S units lower in signal strength on a receive basis compared to the regular dipole. Now, here's the thing, right? If I'm on 80 and 40 meters, there tend to be a lot more static crashes, a lot more electrical type noise or plasma TV type noise. It does kind of reduce that noise there. So the signals do tend to be cleaner and more readable, even though they're at a little bit lower volume. They are a lot more readable than the standard dipole. The other thing too is you'll also find from oh, what was I going to say here? Not in reference. It is less noisier. Oh, but on the bandwidth side, a 40-meter dipole is a 40-meter dipole, right? So here I have the ability of putting a similar antenna in the same footprint and cover 40 meters, 30 meters, and 80 meters with the same, and 60 meters with the same type of antenna and still have that low noise but broader bandwidth capability.
Okay, thanks on that. Are there any other questions that are that you'd like to ask through the chat feature? A comment that John K0UBA has made is about the spacing of the dowels to prevent tangled wires and allow rolling up on both sides of the antenna, like the B&W. It has a number of them as well. Any comments on that, John, even for the materials you might use for spacers?
Yeah, I kind of looked at the diagrams. I think the B&W one has 3. I have obviously one at each end and then one in the middle of mine because mine's a shorter one. The longer one I used, I just ended up using some dowels that I had, and I just wrapped the wire around the dowel, put the dowel on the wire and just wrap tape around it and put a tie wrap on it just to throw it up in the air and to try it out. And if it made sense, then I would sit down and drill out you know, the different spacings. It does help with the tangling of the wires, but I think the larger kind of plastic tube or cardboard tube from wrapping paper or something like that would help you prevent the wires from tangling. And this is really more if you're throwing it in your car and putting it into, you know, a bag and taking it out for field day or something like that.
Okay, great. There was a link earlier in the chat on a calculator for the folded dipole. What about other website links for this particular design that will enable them to, you know, kind of not only design but also a step-by-step construction?
Yeah, I haven't put anything or given any thought to step-by-step construction. It's kind of, I don't know, in my mind, putting antennas, it could be pretty straightforward, but if somebody's having a challenge or wants some guidance, just email me and I can give them a hand on what I went through for it. And maybe now that, you know, this has kind of been published with you guys there, maybe I'll put something up on my blog afterwards. I really didn't want to do anything just to kind of do the reveal with you guys first, but I could put some ideas around building this. There are a bunch of different places. If you go poking around on the web for T2FD, you'll find Corpy .biz. He's got some great ideas there. There's a guy in France. There'll be another guy. There may be some brief stuff on my website, but hopefully you'll find something that can help you. If not, I'd be more than, you know, able to help you out.
Okay, great. Another comment that Stuart G3YSX mentions is about making resistors in a PVC tube using copper electrodes in a solution of copper sulfate. Besides just wire wound or carbon resistors, any other thoughts on the resistor?
I have no idea what the guy's talking about. I was thinking a mason jar with a lemon in it and some water and some wires, and maybe that's how you made a battery. So I would be reluctant to try that without looking up the hazardous material list on it, but it sounds very, very interesting, and maybe we can put that underwater or something like that. But I'm gonna be Googling that to see if I can get some more interest there from personal notice. But there's probably one thing I should say is the resistance elements need to be carbon type resistors. Do not use wire wound resistors. I'll update my my thing for that. I was thinking about it the other day, and then I just realized I don't have it in there because they're going to be somewhat reactive. There's no loading. You're not going to be using any loading coils for this at all. This is really a folded dipole that, based on the way that it's made out, offers this 5-to-1 bandwidth, because you could make a folded dipole for 40 meters just using 300 ohm twin lead, measuring it out, shorting at each end, and then having the other thing coming down. You could do it that way too, but it's still going to be a 40-meter dipole. But inherent in this design with the spacing, the balun and the resistive element is what gives us this higher bandwidth. So making a loaded 80-40 meter version of this antenna is not going to work by using loading coils.
Okay, yeah, you mentioned about the loading coils. The other part to that is like traps. Have you seen any use of traps?
No.
Okay.
This is pure folded dipole. Just take a piece of wire and run it through one dowel, run it through the end dowel, run it through the other end, put the resistor in between, and then put a mount on it. It's basically a a folded dipole.
Okay, and Stuart came back and mentions we use the copper sulfate resistors in high power laser flash lamp discard circuits, and they were handling the pulse rise times. So voltages, I mean, would be standard based upon the radio, the transmitter that's being used. So I'm not sure if it's a little bit of overkill by doing the copper sulfate method. Or if there is some other things that might be happening as a result of experimenting with that too. But I've, like you say, I've never heard of that use before. It may be interesting to experiment with.
If Stuart's got some, if Stuart does end up using that, why doesn't he send his findings into Sprat as a one-page update to, you know, with how he's making this T2FD antennas? So I could see what he's doing there with these special sulfate resistors.
Yeah, no, I found that, again, I found that very interesting that he brought that up. We have a few minutes left. Again, if there are any more questions or such before we go into the evening session, the wrap-up session is going to be in about 15, 20 minutes. And I want to make sure to invite everybody to that. Wrap up kind of what we all had done today on the various sessions, because I know some folk had either come in later like us from the States or were in another stream. But again, I do invite you all to participate in the wrap-up session tonight. I do have someone asking for the link that Anthony had sent. I'm going to see if I can get that posted for you all here in just a moment. Bear with me for just a second. See if I can get that posted for you all. And reposting that. I know, Anthony.
You're on and off mute, Mark, I'm afraid, somehow.
There we go. Okay. Anthony, if you're still on on board, if you can repost that link, I'm trying to get over to that link, and I'm having a little bit of difficulty with it as well. And that I'm trying to copy and paste within the chat.
But I'll answer Chris's question in the meantime. So Chris, according to the formulas, there is a variation in the spacing anywhere from, I think, 15 inches to maximum 36 inches. I just chose to use 18 inches. I think there could be a difference in there. Maybe that's why my SWR patterns or maybe initial patterns weren't as great as I thought it would be, looking at what some of the other results were. So I just ended up just leaving it at 18 inches. At one day, I'd like to experiment, but the last thing I want to be doing is sitting in the garden, you know, with 3 VNAs running and trying to figure out if it's 18 and 24 inch and pushing it into RBN now that I learned about that in this morning session, which is great. I'd rather just get the antenna, throw it up in the air, go try to make some contact. If I can't work the UK with that antenna and I can work the UK on my dipole, then that tells me that T2FD antenna is not good for me to work the UK. I'll just continue to use the dipole. But I've made contacts all around with it. It's not a DX antenna, but it's a pretty good antenna for what it is.
Yeah, and again, I'm still trying to get that link that Anthony had posted earlier. And for whatever reason, I'm having the same trouble that y'all are having. I can get back to it, but I'm not able to copy that link. We'll try and get that information. Yeah, I'm trying to work a couple of things at the same time, so I'm muting myself as I'm trying to paste this. Anyways, I posted John's address. I don't think that modeling is on that particular site.
No, it's not. I could ask Chris to resend me his modeling diagrams that I think he did one for 3.5 meg and 7 meg. So, you know what I'll do is just post it on my blog there and use that as an update for it. And if maybe give some thought to putting some instructions or some tips in order to make it simpler to put this thing together.
And what I'm doing now is I'm putting the home site, and you may have to at least go through this individual's content to see what he's got on there. That's m0lkk .co.uk. At least I'm sorry, that's LMK. Excuse me, I screwed up on that. But oh, there we go. Mitch got that. Thank you, Mitch. Appreciate that. So if there are no other questions, we'll move on to the evening session in about 10 minutes or so. I appreciate everyone who's attended. And again, if you have any last questions, this is your last opportunity to do that before we let John go. And as you may see, John, that everyone's enjoyed the presentation. Again, we thank you for participating in that, and everyone who has.
Glad to be a part of it.
So with that, again, hope to see you all in this evening's session and as well tomorrow. There's a lot of good things happening tomorrow as well. So with that, I'm going to go ahead and close out the session and go from there. Appreciate it all.
Thank you.